Assalamu alaikum. My name is Sabah Maqsood and I'm a student of A University Islamabad and I'm currently doing mechatronics engineering. So today I'm here to show you my lab task 9 of microcontroller and embedded system lab. So basically my task was based on PWM, which was lightness of LED increases gradually from 0% to 100% and then decreases from 100% to 0% as if sun rises and sets. In its concept was based on duty cycle, in which activity 1 was connect a switch to a pin on one of the ports. Use this switch for choosing the duty cycle of the generated wave. So basically duty cycle, we had to put duty cycle uh, 30% and then 100%. So basically, first of all, I'm going to tell you what is basically PWM. So PWM is basically pulse width modulation, which is a method of reducing the average power delivered by the electrical signal by efficiently chopping it up to discrete parts. So basically it's a kind of it makes a kind of waveform, which reduces power which is delivered by the electrical signal. So basically it cut it into different parts to reduce its power consumption. So basically it's based on that principle. PWM is particularly suited for running inertial loads such as motors, which are not as easily affected by this discrete switching because the inertia causes them to accelerate slowly. So basically this is one application. So the term duty cycle describes the proportion of on time to the regular interval of the period of the time. So basically here our duty cycle, we have to put duty cycle first 30% and then 50%. So basically it is on time, for which we have to glow the LED. A low duty cycle corresponds to low power because the power is off for most of the time. So when it is 100%, it is completely on. That means that it is here shown in the form of graph here. So and in simulation we will show it in the form of LED. So basically when a digital signal spends more time in the on state than the off state, it has a duty cycle of less than 50%. And when a digital spends more time in the off state than it is on state. So basically here it is shown in the form of graph that this is 50% duty cycle, and for 75% duty cycle, that means that LED will be on for more time than it's off, and in less than 50% the LED glowing time will be less, and same goes for waveform. So basically first of all I will show you my simulation. So basically I have uploaded my hex file here already, as you can see. So basically whenever I will run this code, my simulation, the LED will glow slowly. As you can see here, it will now glow. As you can see, it has grown because I have given it less delay time. So it will glow and then it will gradually stop. I mean it will turn off and then it will be turned on again. So basically in my simulation it is showing that it is more than 50% showing duty cycle. So basically it is its duty cycle is less than 50%. That means that it has duty cycle of 100%, as it was also mentioned in our manual. So basically it will gradually turn off. So basically after some time it will gradually turn off and then it will be turned on again. Because of more delay time, maybe it's taking a lot of time, so it will turn off gradually. I've tested it before. Now coming towards my code. So basically this is my code. I've given it delay function. So basically first of all I have defined port pin 6 of port D, which is pin 6 of port D, that is IO 6 of port D. I have connected LED to it, and then I have defined two registers. One is timer counter compare register A, which we studied in lab 5 basically. So it is a kind of timer counter register. These bits control the output compare pin OC0A behavior. If one or both of the COM0A bits are set, OC output overrides the normal put functionality. So basically, this is the functionality of this register, which is used for PWM, and its working is based on WGM 2, COM012, and as you can see here, what is basically WGM? It is waveform generation mode, and COM is basically compare output mode. And because of these two modes, it is defined that which mode should be followed. That is normal mode, CTC mode, fast PWM mode, or phase correct PWM mode. Waveform generation mode bits affect the counting sequence, while the COM bits control whether the PWM output generated should be inverted or not inverted. For non-PWM modes, the COM bits control whether the output should be set, cleared, or toggled at a compare match. So basically, this is working um, of register. So here we have defined these COM A, WGM 00, and WGM 01. Then I have used masking register, which is used for uh, enabling the interrupt. So basically, it is used for interrupt enable. As you can see here, timer output interrupt enable. So basically it is enabling that. Then I have used OCR0A. So basically it is output compare register for A, in which we have defined the formula, which is duty cycle by 100, which is multiplied by 255. Then I have used TCC R0B, which is again like this, timer counter compare B. So basically we have also studied that in lab 5, which is I, as you can see, it's working here. So basically the three clock set bits thus select the clock source by which is used to be by the timer counter. So basically this is the working for TCC R0B. And then I've used while loop, in which I have set time delay 100, and if I again increase this time delay, LED will take more time to glow, and I have set the duty cycle to 10. And if the duty cycle increases than 100, then I have set it to 0, and so that it should not exceed more than 100. Then I have called the interrupt function, and I have defined interrupt function here, which was defined here. So basically I have called this formula in interrupt function. So basically this was my working of lab 7, my LED glow with time. So if I change my delay here, as you can see, if I change my delay here, if I put it to 1000 and I build my solution and debug it, and again upload my hex file into this, it will take more time to glow, as you can see here. Yeah, it has grown up. So basically this was my lab 9. Thank you.